Sophisticated scheduling requirements caused by hardly foreseen disturbances have created a new challenge for the manufacturing industry, especially for job shop scheduling problems in the reconfigurable material handling systems. The predictive-reactive job shop scheduling approach has proven effective, but the problem is NP hard. Therefore, the planned production schedules become ineffective in actual execution. The combination of simulation and optimization, together with the implementation of heuristics and evolutionary algorithms, can effectively overcome this problem and reduce the throughput time. The graphs show the statistical analysis of schedule changes in Malaysian manufacturing industries. Application and commercialization potential. The developed predictive-reactive scheduling tool PReS is a comprehensive scheduling tool for practitioners, manufacturers and job shops companies, and teaching and learning purposes. The algorithm provides rapid and effective results in searching for the best solutions during complex routing and sequences scheduling and rescheduling problems. As the proof of concept, the PReS has been adopted at the Smart Manufacturing Demonstrator System. The PReS architecture. The PReS is developed in the environment of discrete event simulation software to ensure the combination of simulation and optimization algorithms. A discrete event simulation software from Siemens, Technomatic's plant simulation, has been used for the development. The genetic algorithm is selected for optimization. With the provided inputs, the PReS, with its innovative algorithm, will perform several experiments on the system model. The PReS algorithm will find the optimal material paths and job sequence that provide the shortest make span and throughput times. The PReS will create the optimized schedule. Since the system model is connected to the control model and linked with the physical system, cyber-physical system, the real-time data is collected and stored in a local database. If disruptions, machine breakdown, job cancellation or increment, and new priority jobs happen, the PReS algorithm will use the real-time data and analyze the effectiveness of the current schedule and strategy. The PReS will then execute new experiments and create a new optimized schedule when necessary, reschedule. The new optimized schedule will be created and directly implemented at the physical system. The novelty architecture and algorithm. The PReS architecture integrates simulation, optimization and physical system, using a generic control strategy for piloting the implementation of a complex scheduling challenge in job shop scheduling problems. The algorithm for scheduling has proved to be effective in solving the complex selections of routes and sequences. The feasible schedule will be computed and fine-tuned with the rule-based simulation system, and then tested with the physical system, which is the reactive part. A genetic algorithm is used to select the best solution of operation machines, parts input sequences and transportation routes. The figures show the two algorithms used in the PReS. The demonstration of the PReS will be shown after this. This is the simulation model built regarding to the Montrac reconfigurable material handling system. Left side is the system layout while right side is the methods and data that used to control and manage the simulation model. You can choose to see the simulation process of the system, and also can control the speed of the simulation process. The faster the speed you adjust it, the faster the simulation model run. This is the visualization of the simulation model, and the simulation data will be stored inside the software itself for other purpose. Now let's look at the user interface settings. This is the place where you can set any settings you want for the simulation run. You can choose whether to keep the process sequences, which release control and path generator complexity level options you want, and also the scheduling mode. For Data tab, it will be showing the input data that had been attached into the software during the model constructions, include the workplaces plan and the process plan. The Scheduling tab will be displaying the dispatching rules options and also the objective functions. While the Evaluation tab will be showing the results of the simulation process. The GA wizard can be opened from the UI. The GA settings can also be manually entered. The Run tab will be showing the GA process details. Now, let's start the optimization process. This process will help to find out the most optimized schedule for the system based on the input data. You can observe the GA optimization process here. The detailed recordings can also be observed. The process is updating on time when the optimization is running, which include every single individual and generation. In the Evaluation tab, the more detailed observations can be displayed, include the best individual, intermediate results, the offspring diagram, the evaluation process and so on. Now, let's the optimization process run until it's done. Different number of generations and generation size results in different optimization time needed. When the process is done, a report will be displayed. The best fitness value, the running time of the optimization, the best parameter of allocation problem and sequence problem will be shown. The best fitness value is also displayed in the performance graph. Lastly, you can also generate the overall schedules for the whole process. You just need to enter which parts or machines you would need to consider inside the schedule. That's all for the demonstration of the Technomatics plant simulation model. In conclusion, the combination of simulation and optimization algorithm with the predictive-reactive approach in PReS increase the capability of reconfigurable material handling system in complex scheduling and rescheduling problems. Several case studies have been conducted, and the result shows that almost 55% reduction in manufacturing throughput times. The developed scheduling tool, PReS, is currently at the TRL6 technology demonstration. The PReS development will be continued with TRL7, TRL8 and TRL9. At the moment, 2 copyrights have been approved as the intellectual property (IP) for this development. That's all for the presentation of the predictive reactive scheduling tool PReS. Thank you.